Again, welcome to Software System Design course. This is introduction lectures, our first lectures for this course. Our main objective, again, is to go through the frequently asked questions about software engineering and also the essential attributes of a good software, and also the purpose of a software or what is the main reason why we use software. So as we know, a computer software has become a driving force. A computer software is the main engine that drives a business decision-making. A good example would be the data mining or machine learning software applications. These softwares can again help managers or CEOs in the companies for decision-making process. Also, a software serves as the basis for modern scientific investigation and also engineering problem solving. And now, the economics of all developed nations are depending on a software. More and more systems are software controlled. And also software engineering is concerned with theories, method, tools for professional software development. The expenditures on software represent a significant fraction of GNP in all developed countries. Also, software delivers the most important product of our time, which is information. So software transforms personal data, such as individual financial transaction, so that the data can be more useful in a local context. Software also manages the business information to enhance competitions. It provides a gateway to worldwide information networks. Example would be the internet. The internet again comprises of a hardware and also a software. So software costs often dominate computer system costs. The cost of a software on a PC are often greater than the hardware costs. And also the maintenance of software is very high cost than development process. So for system with a long life, maintenance costs may be several times more than development costs. Software project failure. Here we said that as a new software engineering techniques help us to build larger and more complex system, the demand changes. Systems have to be built and delivered more quickly. Also, larger and even more complex systems are required. Also, systems have to have a new capabilities that were previously thought to be impossible. Now, failure to use a software engineering method that can lead to a software project failure majority. So here we say it's fairly easy to write a computer program without using software engineering method and techniques. But many companies have drifted into software development as their products and service have evolved. They do not use software engineering method in their everyday work, but consequently, their software is often more expensive and also less reliable than it should be. And there may also be a chance there will be higher software project failure consequences. Now, software also is developed or engineered. And software is not manufactured in the classical sense, although some similarity exists between the software development and hardware manufacturers. Software costs, as we said, are concentrated in engineering. So this means that a software project cannot be managed as if they were manufactured. Now, these are some of the frequently asked questions about software engineering, and we shall go through each one. The first is, what is a software? Here we say a software is a computer programs and associated documentation and possible library files. So a software product may be developed for a particular customer or may be developed for a general market. Now, what are the attributes of a good software? A good software should deliver the required functionality and also the performance. So here we are talking about the requirement analysis. When we talk about functionality, we mean the tasks the software have to do. You have to do it, and also a good performance on it. So the required tasks and also the performance to the user. Also, the software should be easy to maintain. So maintainability, also dependable and usable. The user friendliness also will be a very good attribute for software. Now, what is a software engineering? Here we say software engineering is an engineering discipline that is concerned with all aspects of software production. And also, what are the fundamental software engineering activities? So software specification, software development, software validation, and software evolution. And again, we shall go through all these concepts in our future lectures. Now, what's the difference between a software engineering and computer science? Now, computer science will focus on the theory and also the fundamentals, whereas the software engineering is more concerned with the practicality of developing and also delivering a useful software. Now, what is the difference between a software engineering and also system engineering? Now, when we say a system, let's say a computer system or a transaction system or transportation system, or even a human being, our system, a system may consist of many parts. So, for example, when we talk about a computer system, we can mean the hardware, the software, the user, the platform, the procedures or the standard operations, etc. So system engineering is concerned with all aspects of the computer-based system development, including the hardware, software, process engineering, whereas software engineering is part of the more general process. So for example, transportation system, we may talk about the cars, the drivers, the customers, and the riders, and also even the road where the transport. All this will be made of a one system, transportation system. Now, what are the key challenges facing a software engineering? Here we say coping with the increasing diversity, also the demand for reduced delivery times, and also developing trustworthy software. What are the costs of software engineering? Roughly 60% of a software cost are development costs, and 40% are testing costs. And also, what are the best software engineering techniques and methods? In this course, we are going to go through a lot of different methods. So again, it depends on the type of software that we want to create. Sometimes we may say, okay, we are developing a software for a company that security is a very important issue. So in this case, we may use the different techniques, or the time of delivering the software is an issue. The speedness or the performance of the system is an issue. So we may use different techniques. So here we say why all software projects have to be professionally managed and developed. Different techniques are appropriate for different types of system. So for example, a game should always be developed using a series of prototypes, whereas a safety critical control system requires a complete and analyzable specification to be developed. So you can therefore say that one method is better than another method. Now, what's the difference? What differences has the web made to software engineering? Here we say the web has led to the availability of software services and the possibility of developing highly distributed service-based systems. Also, the web-based system development has led to important advances in programming languages and also software reuse. Now, we have a generic software product. We have the generic product, which are the standalone systems that are marketed and sold to any customer who wish to buy them. So example would be a PC software such as graphics, or Microsoft Office application, CAD software, and also computer games, etc. We also have a customized product. These are software that is commissioned for a specific customer or a specific company to meet their own need. Example here is an embedded control system or the air trafficking control software or trafficking monitoring system, maybe for New York City Metro Transit. And also the product specification, we have the generic product. The specification of what the software should do is owned by the software developer. And also the decisions on software change are made by the developer, because this is generic product sold in a market, in a store. But the customized product, the specification of what the software should do is owned by the customer, because these are special software that is developed for a specific business organization. We also have the essential attribute of a good software, maintainability. So software should be written in such a way that it can evolve to meet the changing need of customers. Also, dependability and security issues. So software dependability includes a range of characteristics, including the reliability, security, and safety. Efficiency. Software should not make wasteful use of system resources, such as the memory and also the processor. These are the two major computer resources, the CPU and the memory. And also acceptability. Software must be acceptable to the type of users for which it is designed. This means that it must be understandable, usable, compatible, and other systems that they use. So those are, again, the four major essential attributes of a good software: maintenance issue, dependable, security, efficiency, and acceptability. So that will be the conclusion of our first lectures. And see you in the next lectures. Thank you.